So welcome back, guys, to Skull Hacks, as we have started with networking part and focusing on theory part before jumping into practicals. So this video is based on topology. Topology refers to the physical or logical layout of a computer network. It defines how devices and nodes in a network are connected and how data is transmitted between them. There are several types of network topologies, each with its own advantages and disadvantages. In simple words, network topology refers to the pattern or arrangements in which devices and computer systems are interconnected with each other. There are 5 main types of topologies: bus topology, ring topology, star topology, tree topology, mesh topology. So starting with the bus topology, all the nodes in bus topology is connected to a single cable known as the network backbone. Bus topology is a simple and straightforward network structure in which all devices are connected to a single central cable called the bus. This central cable serves as the main communication pathway through which data is transmitted between devices. Each device on the bus can transmit data, and all devices receive the data, but only the intended recipient processes it, as you can see in this diagram. Advantages are, it is cost-effective, easy installation, and prevent net failures. Disadvantages of bus topology are, there is loss of data, complex troubleshooting process, network interference. Bus topology is less common in modern networks due to its limitations, especially in terms of scalability and susceptibility to disruptions. Despite being less common in modern network architectures, still has practical applications in certain scenarios. Its simplicity and cost-effectiveness make it suitable for specific use cases where its limitations are not a significant concern. It is used in small office, home office, SOHO, network, laboratory, and educational networks, industrial control systems. Next one is ring topology. Nodes in this topology are connected in a circular format forming a ring shape. Ring topology is a network configuration in which each device or node is connected directly to exactly 2 other devices, forming a closed loop or ring. Data travels around the ring in a unidirectional or bidirectional manner until it reaches its intended destination. Advantages of ring topology are improved network management than bus topology, easy installation. Ring networks are relatively easy to expand by adding more devices or connecting additional rings. In a ring topology, each device has equal access to the network. Disadvantages of ring topology are, network crash is common, slow data transfer, complex troubleshooting. Implementing ring topology can be more expensive than bus or star topologies due to the need for repeaters and additional cabling. Ring topology was more commonly used in the past, but has become less popular in modern Ethernet-based networks, which often employ star or hybrid topologies. However, it is still employed in specific applications where its deterministic data flow and redundancy benefits are valued, such as in certain industrial and mission-critical settings. Next one is star topology. In this topology, the devices are connected via central hub, be a computer or a network device. Star topology is a network configuration in which all devices, such as computers, servers, printers, or networked peripherals, are connected directly to a central hub or switch. This central hub or switch acts as a central point of connection and data distribution in the network. All data traffic passes through the hub or switch, which manages and directs the traffic to the intended destination. Advantages of star topology are low error chance, swift efficiency, easy troubleshooting process. Star topology can offer high performance, especially when using switches. Switches can intelligently manage data traffic, reducing the risk of collisions and improving network efficiency. Disadvantages of star topology are central hub. Failure are common. Complex connection. Star topology can be more expensive to set up than bus or ring topologies because it requires more cabling and a central hub or switch. Star topology is one of the most commonly used network topologies in modern Ethernet-based LANs, local area networks, particularly in home networks and small to medium-sized office environments. Its ease of management, scalability, and fault isolation make it a popular choice for many applications. Next one is tree topology. Tree topology is a network design where multiple star-configured networks are connected to a linear bus backbone, creating a hierarchical structure. Tree topology, also known as hierarchical topology, is a network configuration that combines characteristics of both star and bus topologies. It is a hierarchical structure where multiple star-configured networks are connected to a linear bus backbone. This hierarchy allows for the efficient organization of devices and the extension of the network to cover larger areas. Advantages of tree topology are easy installation, efficient troubleshooting process. Tree topology offers centralized control at each star network's central hub or switch. Disadvantages of tree topology are difficult to install security measures, difficulty in reconfiguring the existing nodes. The central bus backbone is a potential single point of failure. If it fails, it can disrupt communication between all star networks connected to it. Tree topology is commonly used in large-scale enterprise networks, especially when the network infrastructure needs to cover extensive physical areas. Its hierarchical structure, scalability, and organizational benefits make it a suitable choice for complex network deployments. Next one is mesh topology. This topology is composed of multiple repeated connections between nodes and shared data. Mesh topology is a network configuration where every device is connected to every other device in the network. Each device serves as a relay for data, and there are multiple paths for data transmission. Mesh networks can be fully meshed, where every device connects to every other device, or they can be partially meshed, where some devices have more connections than others. There are two types of mesh topology: I, full mesh topology; 2, partial mesh topology. In a full mesh, every device is directly connected to every other device in the network. This results in the highest level of redundancy, but also requires a large number of connections and can be complex to manage as the network grows. In a partial mesh, only some devices are connected to every other device, while others have fewer connections. This approach reduces the complexity and cost compared to a full mesh while still providing a degree of redundancy. Advantages of mesh topology are damage to any node doesn't affect the overall connection. High-speed transmission. Data transmission in mesh networks can be secure because traffic is limited to devices that need to communicate. Disadvantages of mesh topology are expensive to set up, complex network management, complex connection. Mesh topology is commonly used in scenarios where high reliability, fault tolerance, and redundancy are critical, such as in critical infrastructure, military communications, and large-scale data centers. Partial mesh topologies are also used in smaller networks and Wi-Fi mesh networks for home or office environments to provide extended wireless coverage with redundancy. So that's all from this lecture. We'll share the presentation on our Telegram channel. This is just the theory part. If you need practical of this topologies, it is done on Cisco Packet Tracer. If you need practical on that, then comment below. So thank you, do subscribe us and join our Telegram channel.